Hello friends, in my previous video I have already derived the drain current expression for MOSFET in case of linear and saturation region. Okay, there we have used the concept of the total amount of charges present in the channel while deriving the drain currents. Okay, so related to that topic, let us try to solve one numerical in our this video. So the question is this: calculate the total charge stored in the channel of an NMOS device if COX is given by 10 femtofarad per micrometer square with W is equal to 5 micrometer, length of the channel as 0.1 micrometer, and VGS minus VTH as 1 volt. Assume VDS as 0. Okay, so see here already, if you know the formula, well and good, but sometimes in examination it might happen that you forget the formula of the total amount of charge stored in the channel. Okay, so for that what you should do, you just try to think in the simplest logical way. Okay, you just first draw the MOSFET general a simple NMOS figure, and you just try to calculate the total amount of charge stored in that channel from the logic how we derived. That is, if you don't want to remember the formula directly, you just apply 3 or 4 logics and try to derive in the examination so that you will get accurate result as an output. Okay, so suppose you don't remember the formula directly, then how will you solve this? So see, first NMOS device is given, right, and we have to calculate the total charge stored in the channel. So better to first draw one NMOS device. Okay, and as VDS is 0 and VGS minus VTH is 1 volt, so obviously we can say that the MOSFET is not in saturation region. So obviously there is no requirement of pinch off concept or channel length modulation concepts are there. This is one point, and the channel will be obviously uniform in width or in thickness because VDS is 0, right? So generally we know that in saturation region pinch off occurs, and in linear region also, that in the source side the thickness of the channel is more compared to the drain side in case of NMOS, in case of MOSFET. So here we no need to think those concepts because VDS is already 0, so that VGS minus VTH is 1 volt. So channel has uniform thickness, we can conclude from here also. So see how you can solve this. So see, this is the basic structure of NMOS device which I have drawn. Gate is connected to the positive potential, source is connected to the ground, and as well as drain is also connected to the ground. So that is VDS is 0 basically. Okay, and here the p-type substrate is there. Okay, and here what happens, that here the channel is formed which is of uniform thickness, and it consists the mobile free electrons. Okay, now if you want to calculate the total charge stored in the channel, you know that the best way is, as you know, here capacitor is formed, and you know from the basic concept of physics that there is a relation in between charge stored and the capacitor, that is C is equal to Q by V. So from there we can apply that, and we can say Q is equal to C into V to calculate the total amount of charge. So C into V GC, because gate to channel capacitance we have to consider, because in between gate and the free electrons which is making this channel, okay, that is in between gate and channel, basically what is happening, that one capacitor is formed. So Q is equal to C into VGC. But will it come as VGC? No, because VT amount of voltage is already dropped due to channel formation. So the formula becomes Q equal to C into VGC minus VT, right? Now simply you can write VGC as VG minus VC. So Q is equal to C into VG minus VC minus VT. Now VG is what we are applying directly, the positive amount of potential in the gate. Now there is now the question is, what is VC or channel voltage? So see, here in the source there are potential, in the drain there are potential. So if we want to consider the potential of the channel, so better to take average. Basically we should integrate the potential of each point and we can get, but for easily getting the result for simplified explanation, I told in my derivation that you can take the average value, because you know that one kind of approximation of integration is taking average, so that we, instead of Vc we can write Vd plus Vs by 2, that is the average of the two terminal voltage of the channel, and this becomes Q expression becomes this. Now generally what we do, we generally short circuit the source. Here although drain is short circuited, so basically this whole term will become 0, but later we will come to that. Now let us try to derive in more general way. So generally we take Vs as 0, so this becomes this, that is Q is equal to C into Vg minus Vd by 2 minus Vt. So Vg is nothing but Vgs, because you know from the derivation that is source is grounded, so Vg equal to Vgs, and minus Vt minus of Vds by 2, right? So basically, so this is the capacitor multiplied. What is the capacitor value? Capacitor is nothing but epsilon Ox by Tox into W into L. Basically the capacitor expression for parallel plate capacitor is epsilon A by D. Here epsilon is epsilon, that is a permittivity of the oxide layer or polysilicon or SiO2 you can say, which is present in between gate and substrate, and Tox is the thickness of the oxide layer. W into L is nothing but denoting the area of the capacitor. Okay, so Q is equal to, just simply we have put the formula of the capacitor, that is epsilon A by D into Vgs minus Vt minus of Vds by 2. Clear? So this we derived. So see, logically if you by chance forget the formula, then logically you can derive. Each steps can be understandable. There is nothing high level concept I have applied. Simple mathematics, simple concept of physics only we have applied here. So now we already got the explanation, that is the formula for the amount of charge stored in the channel. But if you want to solve this numerical in a faster way, you can memorize this, but always I prefer the logical thinking concept rather than memorizing, so that I have shown you again the derivation, although I have shown you the detailed derivation in my previous videos where I have derived the drain current anyway. So basically now there is simple substitution, that is class 5 or 6 mathematics you can say. COX, it is given already. Let's check what is COX value. That is 10 femtofarad by micrometer square. Here in this portion you should have a very quite good attention in the portion of units, because you may mistake if you take it lightly. Femtofarad means 10 to the power minus 15 farad. Micrometer square means 10 to the power minus 6 into 10 to the power minus 6 meter square. So what I always suggest, better convert every units in SI, so that your solution will become easier, and without any mistake you can choose the unit properly. So COX is 10 into 10 to the power minus 15, because 10 to the power minus 15 is multiplied because it was given as 10 femtofarad, right? Per micrometer square it was given. So 1 micrometer square is equal to 10 to the power minus 6 into 10 to the power minus 6 meter square. Then W was given as 5 micrometer, so that 5 into 10 to the power minus 6 micrometer. L was given as 0.1 micrometer, right? See here, L was given as 0.1 micrometer. So substitute that 0.1 into 10 to the power minus 6. So here I have written that. Now Vgs minus Vt was directly given as 1 volt in the numerical. So 1 minus Vds was 0. It is mentioned in the numerical. So 0 by 2, that is nothing but 0 only. Now if you solve using calculator, you can get Q is equal to 5 into 10 to the power minus 15 coulomb, and that is nothing but 5 femto coulomb. See here, you no need to worry about units. Why? Because already you have converted all the units in SI, right? So obviously unit of Q is going to be in coulomb. Now after simplification you have got that 5 into 10 to the power minus 15 coulomb. So we can replace the 10 to the power minus 15 coulomb by femto coulomb, so that we can get that the amount of charge stored in this channel is 5 femto coulomb. But if you want to avoid this last step, if you want to keep the answer as it is, that is 5 into 10 to the power minus 15 coulomb, then also no issue. Okay, so in this way you can solve the numericals based on the amount of charge stored in the channel. Okay, so I hope you have understood. If you want to get the detailed derivation of this, you just go through the link where I will post the link on the video where I have discussed in detail the drain current expression of the NMOS. Okay, so practice more and more related to MOSFET numericals, because most probably all the questions which is going to appear in examination related to semiconductor device or VLSI paper, most of the numericals, at least you can suggest 90% numericals, or you can also prepare for 100% numerical in VLSI or semiconductor paper, at least for our university, VIT University I am talking. Okay, so this is all for my this video. Thank you for watching.